This is the Constellation Year in Review for 2009. Constellation is America's new space program, which has the flexibility to take crews to the International Space Station, return humans to the Moon, and even extend human presence beyond. NASA centers around the country are working together to design, test, and manufacture hardware for this new era in human space exploration. From the Kennedy Space Center in Florida, NASA took a huge step forward in its exploration goals with the flight of the Ares 1X. An unmanned test vehicle, the Ares 1X was loaded with 700 sensors to monitor every aspect of the flight, providing engineers with volumes of data to be used to improve the design and safety of the next generation of human spaceflight vehicles.
Ignition and liftoff of Ares 1X.
At liftoff, the over 300-foot rocket produced 2.6 million pounds of thrust, accelerating to near hypersonic speeds. The flight test included separation of the first and second stages, monitoring of controllability and aerodynamics, and the re-entry and recovery of the first stage solid rocket booster. Ares 1X not only tested the rocket design, but also provided an opportunity to test facilities and ground operations. The ground rumbled again in Promontory, Utah, where another test for Constellation took place. Development Motor 1, or DM1, is the first test of a 5-segment solid rocket booster in the Ares rocket configuration. Similar in design to the 4-segment shuttle solid rocket motor, DM1 features several upgrades and technology improvements, as well as the 5th segment needed to deliver its 3.6 million pounds of lifting power for the Constellation program. Other rocket tests, including the firing of the first stage igniter and the ullage motor test, further advance the development of hardware as it moves from the drawing board to the test stand. The crew exploration vehicle for Constellation is called Orion. Orion borrows its shape and aerodynamic performance from Apollo. However, the new spacecraft is greater in size than Apollo, featuring updated computers, life support, electronics, heat protection, and other systems. This year, Orion completed its preliminary design review. This major milestone in the spacecraft's development approves how all of the systems of Orion will work together when built. At the NASA Michoud Assembly Facility in New Orleans, Louisiana, construction continues on the Orion Crew Module ground test article. The full-sized module will be tested in a variety of ground-based simulations designed to recreate the Orion flight environment. The structure will then undergo mechanical assembly, integration, and testing in New Orleans and Denver, Colorado. This year, the Constellation program completed its first post-landing Orion recovery tests, or PORT. Simulating a recovery in the open ocean, PORT not only reveals to engineers how the spacecraft will behave in these conditions, but also gives recovery teams their first experience with recovery procedures and gear. Sitting on top of Orion is the launch abort system, designed to pull the crew to safety in the event of an emergency on the launch pad or in the early stage of the climb to orbit. Preparations are in full swing for the first test of the multifaceted launch abort system. Called Pad Abort 1, the test simulates an abort while still on the launch pad. Components include an abort motor, which pulls the Orion spacecraft from danger, an attitude control motor, which provides directional control, and a jettison motor that separates the system from the crew module. The Pad Abort 1 test will take place at the White Sands Missile Range in Las Cruces, New Mexico. A 92-acre launch facility has been developed to support this and other Orion flight tests. Parts for the Pad Abort 1 test rolled into White Sands, including the Orion Crew Module. Outfitted at the Dryden Flight Research Center in California, the crew module contains an array of sensors to help analyze the flight test. The crew module joins the abort motor, jettison motor, and other launch abort system components, which will all be assembled together for the test. Other activity this year included parachute tests for a rocket deceleration system, managed by the Marshall Space Flight Center in Huntsville, Alabama, and taking place at the U.S. Army's Yuma Proving Grounds in Yuma, Arizona. The tests featured the largest rocket parachutes ever manufactured. The 3 main parachutes measure 150 feet in diameter and weigh 2,000 pounds each. They are designed to slow the descent of a 5-segment solid rocket motor and provide a soft landing in the ocean, allowing crews to recover and recycle the stage for a later launch. Constellation is engaging the talents of engineers, scientists, and manufacturers across the country, with every NASA center involved with its development. From flight tests to wind tunnel testing to computer modeling to manufacturing, Constellation is trailblazing relationships between NASA centers and commercial industry. With the first flight test complete and more on the way, engineers are learning more about how real hardware behaves in flight conditions. The knowledge gained helps engineers work towards safer and more reliable spacecraft.